Hi everyone, hope you are doing good today. I'm going to start a new chapter, chapter 3, which is descriptive measures. So now I'm going to explain you how we do our measurements, how we take our measurements in statistics. Those are we call descriptive measures. Uh, Under this chapter 3, there is a subsection, section 3.1, measures of central or measures of central tendency. So, this measure represent the data set variation or data set deviate, data set go beyond from the central. So we can measure how much my data set has gone away from its center. So there are three central tendency measurements. We call them mean, median and mode. Mean of the data set is the sum of the observations divided by the number of observations. So simply mean or average. We can use both terms. Mean or average is equals to sum of all the observations divided by number of observations. So you can see in example 1, exam scores for 4 subjects for a student in a class are 88, 75, 95 and 100. Calculate the mean of the 4 exam score. So how do we calculate the mean? Mean is equals to sum of all the observations. So these are my observations. So sum 88 plus 75 plus 95 plus 100 divide by number of instance. How many? There are 4 subjects. So divide by 4. This gives me mean of the 4 exam scores. So when you calculate this, you will get a value. This value we call mean. And also here, the example 2, the mean weight of 5 complete computer station is 167.2 pounds. Okay, the weight of 4 of the computer stations are 158.4 pounds, 162.8 pounds, 165 pounds, 178.2 pounds respectively. Then what is the weight of the 5th computer station? Okay, here you have to use the same equation which I used earlier. Mean equals to sum of instance divided by total number of instance. So mean, say I can use this one. Mean of 5 complete computer station is this much. They have given that value. So mean now it is 167.2. This is the mean. This equals summation of all the uh, weight of this computer. There are 5 computers. They have given 1, 2, 3, 4. We need to find what is the weight of 5th computer. So if I suppose that weight of the 5th computer station is let's say y is my 5th weight of the 5th computer. So I can write this summation of weights of these computers 100 and 100 158.4 plus 162.8 plus 165 plus 178, I'm sorry, 168.8, 165 plus 178.2 plus y, weight of the fifth computer, divide by total number of computers. There are 5 computers, so divide by 5. When you solve this, you should be able to get the value for y, get the value for weight of the fifth computer. Okay. Okay. Next one. So central tendency, we have 3 things: mean, median and mode. So the second one is median. Median means the numbers divide the bottom 50% of the data from the top 50%, which means middle value of the ordered list. So median mean, if we ordered my list, my observation list, the middle guy is the median. So we need to arrange our data into ascending order. We need to arrange, in the first place we need to arrange our data into increasing order, ascending order. The number of observation is odd, number of observation is an odd, then the median is the exactly middle point. If the number of observations are even, then the median is the mean of the 2 middle observation in the ordered list. Okay, this idea we can convert into a very simple formula. So formula I have mentioned here. Again, I'll write down it for you. If my number of observation, if I consider it is equals to simple n plus 1 divided by 2, this gives me the median position. This is not a value, this gives us the position of the median value. You have to locate to that position and take the value. Okay, I'll explain it more in this example. So when is odd, when n is odd, 1 2 3 4 5 6 7, yes, it is odd. So first you have to convert this value into ascending order sequence. So minimum value is, I think, if I am correct, it should be 2 4 7, then 9 11 19 and 20, 3 6, yeah, 7. Okay, there are 9 values, n equals 9, sorry, not 9, 7 7 7, I'm sorry, n equals 7, there are 7 values. So 7 is an odd, so we can use this equation to find the position of the mode. N plus 1 divided by 2, so n is 7, 7 plus 1 divided by 2, it is 8, 8 divided by 2 is 4. Fourth position, fourth position. So you have to locate the fourth position which belongs to our median. So 9 is the median in our data set. what happen if we have an even number of observations? So in this case we have example 4, we have even numbers. First of all, you have to set this sequence into ascending order. So I can see that 24 is the minimum value, 24, then there are two 25s, 24, 25, then I can see 27, 30, sorry, 30, 32, 1, 2, 3, 4, 5, 6. There are 6 values, so n equals 6 here. So in this case you have to do a little bit more work. Again, you can use n plus 1 divided by 2 equation to find the position. So median position is n plus 1 divided by 2 is n is 6, 6 plus 1 divided by 2, it is 7, 7 divided by 2, it is 3.5, 3.5 position. So do we have a position like 3.5? We don't have a position like that. We have positions 3, 4, 5, something like that. So that you have to go back to your sequence or your observations and pick the third one and fourth one, third position and fourth position. So let me change the color. So you have to pick the third position and fourth position value and take their average. So third position is, oh I'm sorry, third position is 25 and fourth position is 27. So you have to add this 25 plus 27 divide by 2, take the average of these two. So this gives you 26, right? Again, 26 value is not in this observation, but that's our median. There is no rule that median should be always in this observations. No, there is no such a rule, so you can do this math. Okay, next one, mod. Mod mean the most frequent value. In my observations I have uh, frequent value, then I can get that value is my mod. Find the frequency of each value in the data set, then we can decide, okay, highest frequency goes to the mod. In any case, if I have no value occurs more than once, then in that particular data set there is no mod. Otherwise, if any case that value occurs with greatest frequency is the mod of that data set. Mod, there can be one mod in the data set, two mods or many. Okay, if I have most frequent values for two values, then those two values are the mods. Okay, there is an example and you can use this example to find mean, median and mod, all three values. I'll do one example and you can do the rest of them and practice. Okay, I'll do first one, example 5. So how do we find mean? Mean is equals to, okay, let me get the pen. Mean equals to mean, I know why this is not Okay, mean mean is equals to mean is equal to summation of all observations. Here it is, let's see, 24. Order doesn't matter. 25 25 plus 27 30 plus 32 divide by number of observations. There are 1 2 3 4 5 6 observations, so you can calculate the mean by using your calculator. Okay, this data set is, yeah, it has it's in its ascending order, so I can directly find my median. Median is the mid value in my data set. So median, how we find? N plus 1 divided by 2, its position is the median value. So n plus 1, n is 6, 6 plus 1 divided by 2, so 3.5 position. So what is the 3.5 position? 3.5 position mean third position and fourth position. So take the third and fourth position values, add them together, divide by 2. So 25 plus 27 divided by 2, you will be having 26. This is your median. And okay, so how do we find the mod? Mod is the highest frequency value. So you can see 24 once, but 25 twice. So mod goes to 25. So this is how we find the uh, central tendency measurements, mean, median and mode. Likewise, you can continue this example 6, 7 and 8 as well. In this table, they have given two data sets, two different data set, which mean size of this data set is different from the other data set. First data set has 13 values, second data set has 10 values. So I have summarized mean, median, modes of salaries in dataset 1 and dataset 2. As you can see here in the last table, measure of center, mean, definition, sum of observations divided by number of observations. So for the dataset 1, mean is 483.85. For dataset 2, mean is 474. Median is the dataset 1 400 and dataset 2 350. Mod is 300 for dataset 1 and again 300 for dataset 2. When you check these values, you can see that median value is always less than mean value. Okay, we will see what is that. In both sets, as I mentioned, mean is larger than median. The mean is affected by the few large salaries in each data set, because in each data set there are a few large values. Properties of the mean. These properties are critical properties. Mean or average is the balance point of the data set. Mean is highly influenced by outliers. What is this outliers? First of all, this outliers mean extreme observations, which mean that particular observation is far away from our normal observations. So this kind of observations we call outliers. They are far from our particular observations. So that mean is highly influenced because we consider each and every observation to calculate the mean. So it is a disadvantage. What about property of median? It is the midpoint of the data set. Median is not influenced by outliers. Yes, why? When we calculate the median, we do not consider value of each observation. We consider their position. So when we consider their position, it doesn't matter whether we have outliers or not. So that a plus point for the median. When we have the choice of the measure of center is between the mean and median, median is usually preferred to uh, preferred for data set that have extreme observation. If we know that we have extreme observations, then the best measure of center is median, not the mean. Okay, this is a relative position of the mean and median. So as you can see here in the first graph, median value is less than the mean value. From left to right, values are increasing. So in the first graph, median value is less than the mean. So that we call it right skewed because it's tail in the right hand side. So we call it right skewed. If mean and medians are equal, we call it is symmetric. Picture B. If mean is less than our median, we call it left skewed. So I recommend you that if you can, please remember these three properties. Okay. So mean is pulled into direction of skewness, that is in the direction of extreme observation. So in the first picture, why mean goes to right hand side? Because there are extreme observations, same as the picture C. So resistant measure not sensitive to the influence of few extreme observations. So resistant measure mean that measurement does not influenced by the extreme observations. Simply we call uh, outliers. So we can say median is a resistant measure because it is not influenced by extreme observations. There is a notation we are using in statistics called uppercase Greek letter sigma. It is the notation for summation. We denote our summation using this sigma notation. Bottom of this summation notation, we use our variable. I goes from 1 to top of this Greek letter sigma, we denote the endpoint. So I start from 1, go up to k. Xi is the uh, variable value. X is the variable, I mean its index. So when I equal 1, which mean x1, I equal 2 mean x2. So this notation denote the summation. So we have to sum those values from x1 to xk. Okay. For an example, student take 4 exams. Okay, student takes 4 exams in class and grades are 88, 75, 95 and 100. X denote the variable exam scores. Okay, X is the exam scores. So X has these values 88, 75, 95 and 100. These are values belongs to X. Values belong to X. So what is X1? It is 88. X2 is 75. X3 is 95 and X4 is 100. So as we can see here, summation of xi's I from 1 to 4, because we have only 4 observations. Xi is the exam score. So x1, x2, x3, x4. You can add them together and find the exam score. Okay. So from beyond this point, we are using this summation notation. Okay, it is simply as x1 plus x2 plus x3 plus up to xk. K is a value. So definition of a sample mean, we can rewrite mean is equals to summation of xi denoted by n. Sometimes we don't write this I goes from 1 to k. We just simply write it summation like this. Okay, divide by n. This is how we find the mean. Here mean, for the mean, sample mean, we denote by x bar. X bar. X bar. We call this x bar. Okay, we call it x bar, which is the sample mean. Summation of xi divided by number of observations. So summation of xi mean a summation of observation values divided by number of observations, or simply sample size. Number of observations equal sample size. In this case, blood pressure of 5 children is this. So we need to find x bar. So what is the equation of x bar? It is equal to summation xi's divided by n. You know what is n? N is 5. Summation of xi 81.6 plus dot 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 82. Okay, you have to take these values, divide by 5. Now you can find what is x bar. Measure of variance, measure of variation. We have done how to measure the central tendency. Now we are going to measure about the variation about my data set, how it spread, how my data set is spread, that denote in measure of variation. There are few variation techniques, so we will talk about them step by step. You can see here there are two teams, including 5 members in each team. I have mentioned their heights in inches and yes, feet and inches and inches only. Okay, let's consider their heights in inches. That's the easiest one. So if you consider team 1, 72, 73, 76, 76 and 78. So you can see in team 1, 76 height, the frequency is 2, so mod, definitely 76 is the mod, right? And you can find what is the median and what is the mean as well using our equations. Same thing in team 2. Okay, let's see what we have to do. Okay, in here we have considered the shortest guy and the tallest guy in the each team. Shortest guy in the team 1 is 72 and the tallest guy is 78 in team 1. In team 2, shortest guy is 67 and the tallest guy is 84. So you can compare the gap between these two values. So these two values, you can calculate the gap, which is 78 minus smallest one 72. So gap is just 6. In this case, you can calculate the gap. It is 84 minus 67. So how much? It is uh, it is 70. Okay, now you can see the gap between these two here. Gap between these two guys 6 inches. Gap between these two guys is 17 inches. Now we can get an rough idea how this deviates. Okay, you can find the mean of these teams, median. We have done it, mod. So minimum maximum, as I mentioned there, those two teams have same mean height. Okay, if you calculate these values, you should be able to check these things which I have mentioned. Please try to fill this table and check whether these values are true, whether these things are true or not. If you fill this table correctly, you can see that both teams have same mean height, same median height, and same mode. Nonetheless, the two data sets clearly differ. Yes, definitely, those two data sets are different. The height of the player on team 2 very much more than those on team 1. Yes, we saw that. I explained that. Uh, to describe that different quantitatively, we use the descriptive measures that indicate the amount of variation, or we call spread, in a data set. So we use that different or range, or we call difference, to mention the variation of this data set. Such descriptive measures are called measures of variation, or we call measures of spread. So we will talk about more in this section, measure of variation or measure of spreadness, in next video. So up to this point, I hope you guys understand something. So we will see in next video. Thank you very much and have a great day.